These notes are going to go over part one of the linear programming notes. So we're going to take this section by section. And part one is just a quick review of graphing linear equations. Now the key here though is that a lot of these linear equations are not already in slope-intercept form, y equals mx plus b. So what we're going to have to do first, and we see these steps over here, first we're going to have to rewrite the equation in slope-intercept form. Then we will plot the y-intercept. Then we'll use the slope to find some other points. And finally, we will draw the line. So I'm going to get started with question 1 here. I want this to be in slope-intercept form, which if you need a reminder, that's y equals mx plus b. So what I need to do is solve the equation for y. I can do so here by subtracting 2x to the other side of the equation, and I get y equals negative 2x minus 2. Now at this point, I can clearly identify the y-intercept is at 0, negative 2, and the slope is negative 2. Now for a whole number slope, I like to put that over 1 because remember that slope is rise over run, so that'll help us graph it later on. First, plotting the y-intercept at 0, negative 2, here's that point. And then our slope of negative 2 over 1. So we're going to rise negative 2. That would be down 2. And then we're going to go over 1. And there's our point. Then from this point, we're going to repeat that. We're going to go down 2, right 1. Down 2, right 1. And you can keep repeating that down and over. But then we can do some more points in the other direction. So now we're going to kind of almost flip the opposite. Instead of going down 2, we're going to go up 2, and then we'll go left 1. So up 2, left 1, up 2, left 1, up 2, left 1. You can go do as many points as you want to make a nice, neat line. And then we will connect the points for the final line for this linear equation. And there we go. The next one, we've got negative 2x plus 3y equals 18. So step 1, I'm going to add 2x to both sides. And I get 3y equals 2x plus 18. But I'm not quite solved for y yet. I still have a coefficient in front of y. So now I'm going to have to divide by 3. Be careful here because there are terms that are broken up by an addition sign. We need to divide each individual term by 3. So I get y equals 2/3 x plus 6. All right, so now we see our y-intercept is 6, and we have a slope of 2/3. So I'll start at 6 right here on the y-axis, and then I'm going to use the slope 2 over 3, that's rise over run. So we're going to rise up 2, and then we're going to run over 1, 2, 3, and place a point. Repeat again, up 2, over 1, 2, 3, place a point. Now we can also put some points in the opposite direction by doing that double negative, down and left. So we can go down 2, left 3, there's our point. Down 2, left 1, 2, 3, there's our point. Down 2, left 3, and there we go. We have a nice linear function. Now we're going to move on to part 2 of these notes. We're going to bump it up a little bit. Instead of just graphing linear lines, we are going to graph inequalities with linear functions. So the first step is going to be, just like what we just did, rewrite the inequality in slope-intercept form, y equals mx plus b, except this time we probably won't actually have an equal sign. Now remember to flip the inequality if you multiply or divide by a negative value. Step 2, if the inequality is less than or greater than, we get a dotted line. But if the inequality in step 3 is less than or equal to or greater than or equal to, we get a solid line. After we graph the line, then we're going to shade for the inequality. If it says y is greater than or equal to, then we shade above the line. But if y is less than or equal to, we will shade below that line. Let's go ahead and try. The first one, question 1, there's actually 3 inequalities. We're going to graph all 3 together. Starting with y is greater than or equal to 4. First, you want to think of just the line y equals 4. Y equals a number is always a horizontal line. So we're going to have a horizontal line at y equals 4. Determine, before you draw the line, you want to determine though, should it be a dotted line or a solid line? Because this is greater than or equal to, this will be a solid line at y equals 4. So we can go ahead and graph that. There's the line y equals 4. Now we want to shade. This says y is greater than or equal to 4, which means we are going to shade above the line. So we will shade everything above this line right here. So definitely be a good unit to break out your colored pencils. And there's the first one. Let's do the next one. X is greater than or equal to 0. Remember that when x equals a number, that is a vertical line. So x equals 0 would actually be the y-axis. And again, this is greater than or equal to, so it will be a solid line. So we've got a solid line here for x equals 0. And now we're going to shade. This one says x is greater than or equal to 0. So where are the x's greater than 0? That's on the right side of the graph. So we're going to shade to the right of this line here. And then the last one we have, negative x plus y is greater than 2. First thing I need to do is get this solved for slope-intercept form. So I can do that by adding x over, since I want to get y by itself. And I get y is greater than x plus 2. Now I want to graph this the same way we did before. Start with the y-intercept, which is at 2, and then we'll use the slope. So let's get a few more points. Now this one has a slope of 1. There's an understood 1 in front of the x. So 1 over 1, up 1 over 1. So we can get a few points here, up 1 over 1, up 1 over 1. And remember, you can also go in the opposite direction, down 1, left 1, down 1, left 1. And we get the points for this linear function. All right. Oops. But I don't want a solid line. What type of line do I want? If you said a dotted line, you would be correct. Why, though? That's because this is a greater than symbol, not greater than or equal to. So we're going to draw a dashed line here. And this represents that the inequality cannot actually equal the line. It's only the values that are greater than this line. All right, now we're ready to shade, and it says y is greater than x plus 2, so we will shade greater than this line. So we'll shade above it. And you can see now that I've shaded, it's like you can tell where all the different shadings are overlapping the most. All right, and there's our system of inequalities. Let's try number 2. For number 2, the first thing I need to do is solve this first equation and get it into slope-intercept form. So I'm going to subtract 3x over. So I get y is greater than or equal to negative 3x plus 3. And I'm going to go ahead and graph this. We'll start with the y-intercept of 3. And then our slope is -3. Remember, we can think this is -3 over 1. So I'll go down 3, right 1. Down 3, right 1. Down 3, right 1. Go 1, 2, 3, right 1. And then we can go in the other direction too. Up 3, left 1. Up 3, left 1. This line will be a a solid line because it's greater than or equal to. Ooh. And then the equation says y is greater than, so we will shade above this line. So shade this side here. It can be kind of hard when the line is so slanted like this one to tell which side is above. But imagine if you had to stand on the line. Sometimes that can kind of help. Where would it make sense that you're standing upright, even if it's a very steep hill? All right, and then let's draw the other line. So again, step 1, I need to get it equal to y. So I'll subtract over x. I get 2y is less than -x minus 4. But in this one, I have another step because there's a 2 in front of the y. So I must divide every term by 2. And we get y is less than -1/2 x minus 2. All right, and we're ready to plot this. So I'm going to start with the y-intercept at -2. And we have a slope of -1/2. That means I'll go down 1 over 2. Down 1 over 2, down 1 over 2. I can keep going. And then we can also go in the opposite direction. Up 1 over 2, up 1 over 2, up 1 over 2. Now to draw the line, look at the inequality. This is just less than, not less than or equal to. So this one will get a dotted line. Now we're ready to shade. This equation says that y is less than the equation. So we're going to shade below the line. And there we go. That's part 1 and part 2. Another video will go over the next parts.